right, guys, I'm Nicola, and today Brian and I are here to talk about cooling electronics in outdoor environments. So today, more and more people are exploring the effects of the environments on their electronic devices. We see electronics designed for outdoor usage often these days, from digital signage and outdoor cameras to EV chargers and telecom base stations. External devices are equipped with a plethora of electronic components, and those components need to be cooled down. Engineers are faced with these environmental considerations when selecting fans for their designs. They need to consider what the fan will be exposed to: humidity, dust, vibration, extreme temperature, oil-rich environments, and EMI, just to name a few. And they may also need to be made accessible. And this part of the design phase is more complex than typically thought. In fact, sometimes cooling options become more of an afterthought in the design process. So in this video brief, we'll chat with Ryan Murphy, Eastern Sales Engineer, Cooling Systems Division at Sanyo Denki, and Vineet Barot, Technical Support Manager of Thermal at Sager Electronics, about the different environmental considerations when choosing a fan and how to protect from moisture, dust, oil, splashing, and extreme temperatures. So thank you both for joining us today. We appreciate your time.
Thank you for having us.
Sure. Yeah.
All right, guys, so why don't we kick off by looking at the importance of this topic and really the growth of the outdoor electronic systems market. I'd love to start off by looking at how this market has evolved over the years.
Sure. Yeah, no, so there's always been a need for cooling outside for a lot of different reasons. Everybody has thermal issues when they're talking about devices, especially electronics. But as we've gotten more and more advanced technologically with what devices we use outside and more density of power inside devices, fans have become a lot more prevalent of a need, and something that really a lot of people have questions and concerns about. You don't want to have a device in an external environment that's not going to be prepared for those sort of environments. We see a lot of different applications with a very wide variety, as you had touched on, Nicolette. But really what we're seeing a lot of is a lot of a move from just passive cooling that you might get from the environment to need for active cooling and needing to install fans into a device just to keep your electronics cool to where they need to be. This is stuff like outdoor lighting, digital signage, as you had mentioned, inverters for power supplies externally on buildings, electronic vehicles, chargers for those vehicles, as well as a plethora of other devices. So really there's been a large shift in what we're seeing as technology used in the external environment. And we got to take precautions to prevent any damage to the electronics, as well as make it easier for the design engineer to install fans into their system without having any concerns of using those components without having to take extra precautions.
Yeah, we do kind of see two types of customers, I think. Some that have seen what the advancements that we've seen from fan industries and leaders like Sanyo Denki on what fans can do, and saying, hey, I want outdoor equipment that'll do the same kind of performance. I don't want to downgrade my performance, but it's going to be outdoors. And then there's others who are still kind of hesitant to do active cooling outdoors because they think, oh, it's a fan, it's going to get clogged up with dust or whatever. So I think what we're going to talk about today, looking at the different technology, should help a lot of people say, hey, maybe fans are an option for me, even if I'm in an environment where I usually wouldn't consider it.
So here's a question before we get into the advanced stuff. At a basic level, and even sort of like the highest level, why do we even incorporate fans into electronics?
I think the biggest thing that comes down for that is how much power you're actually putting into your device. If you're putting too much power in and you have components on your board or whatever you're trying to add electronics into, heat's going to be a problem. That's always going to be the problem when you're putting electricity into stuff, is how much heat can you generate and not damage something inside your device. And a lot of people can get away with just doing passive heat sinks or whatnot. However, there's a limit. There's a limit to how much you can do with that, especially if you're in extreme environments. Say you have a device that's going to be outdoors in the hot sun in the desert for 24 hours a day, running 365 days a year. You're not always going to have the benefit of the doubt of knowing that you can just get that passive cooling. So you need to take that extra step to do active cooling with a fan to blow air through there and actually make sure that your device stays within a reasonable limit for its device, as well as you may want that extra performance. A lot of devices need to generate more power and use more power in order to be at their peak and optimum capacity. And so in order to do that, you do need to add fans into those systems as well.
So now there's different types of fans, right? There's a ton of variety of fans, and we're developing those for the different applications, like you mentioned, some of those, environments. How do the fans sort of compare to each other? Like, why do we do that? Why do we create certain types of fans for certain environments and other factors?
I think that's a great question. I think really what that boils down to is the different sort of usage cases. I mean, everybody has devices that are used for a plethora of different things. And for each of those different applications, they may have different concerns. Maybe they need the high-end performance, as much airflow through their system as possible to make sure these things are running as cool as possible. Or maybe that's not a big concern. Maybe these are used in an environment that's close and near human contact and they need low noise. Or they have something like a need for actual ingress protection with a lot of dusty environments, or have capability of being outdoors and could get rained on. If a fan gets rained on that doesn't have any sort of ingress protection, that's going to be a major concern for you, because then you have another component that could fail on you. And then on the flip side of that, you do also have a lot of concerns on life of a product. If you have a fan in a product that's sitting on a telecom base station, you have 5G network power up on the top of a mountain up in the middle of nowhere, you don't want somebody going out there to replace a fan if a fan fails. You want to make sure that that's going to be running as long as possible without having a concern with somebody going up there and having a potential of your device going down.
Do you think we can break down some of those types of fans in each environment? Kind of like maybe we look at moisture, dust, water, extreme temperature, and oil. Like what are the differences? What are the characteristics that make it prime for moisture versus dust versus oil kind of thing?
Yeah, absolutely. So Sanyo Denki takes a lot of pride of designing a wide variety of products specifically for all the different usage cases that we've talked about. I think the biggest one that we're seeing a lot of growth in is ingress protection. So IP is the standardized set for determining how much a fan or any device can handle and withstand dust and moisture. Sanyo Denki is kind of on the forefront of designing IP68 rated fans, which means they are fully submersible in water if need be, as well as fully encapsulated and protected from dust. So if you have a device that is going to have those concerns, it's a great option for that. We do that by fully epoxy coating all the internal electronics of the system. So it's fully sealed. No actual ingress can get into the fan and electronics itself. It gives a lot of good peace of mind for somebody that's working with that. Another
oil as well. I know, Brian, when we were talking about this, we were really blown away by the fact that that it can withstand the oil.
Yeah, so oil is kind of the sister product to that. It's very similar in how we do design work. Usually they're encapsulated as well, so all the electronics are sealed as well, but they have a few extra steps that go into it to make sure that they can withstand that oil-proof environment as well. The big ones that we talk about are the frames and the impeller plastics that we use themselves are specific plastics that are meant to be very inert to any sort of oil environments. We actually have customers that do stuff like food processing. So for high-end, high volume usage of packaging of food and processing on a large line, that may be using certain oils for cooking or processing in their own facilities, you got to make sure that the plastics don't degrade from those oils. That's something that many people don't always realize when working with those oils, is that they often degrade plastics relatively easily depending on what you're using. So we design specific materials that prevent that from happening. And then the next big one that we do for the oil proof is actually increase the gaps on any sort of rotating components compared to the frame of the fan. So the impeller itself and the frame are maintained at a larger distance away from each other. It's a little less efficient because those smaller gaps do help you with getting more airflow into your system. However, the benefit is if oil is getting sucked into this fan for a long time and over years of usage, you'll find that oil does build up on the internal side of the fan, and eventually it will gunk up enough to hold everything together and stop the fan in place. So the oil-proof fans are designed to prevent that to some extent.
So you mentioned, food processing, right? With the oil base, is there any other applications where you see where they're using these fans that are able to be submerged for water or even oil?
For oil, really the big target customers for that we see a lot of usage out of are food industry. We have a few guys that do equipment for kitchens, fast food industry, kitchens, anything like that, fryers, air warmers, stuff like that, as well as on the machining side. We see a lot of usage out of these for large machinery that have a lot of the oils from the machining process that they have to be concerned about in their devices. For the splash proof side, it's all over the board. I mean, we see stuff every which way. I mean, we've got customers that do cameras for outdoor usage on highways. They have to have a fan inside to keep the electronics and lenses from fogging up inside their device. And those they often use splash-proof fans to make sure that they don't have any worry about having to go up and change a camera over the top of the highway whenever they need to, as well as a lot of different other applications. One of my favorite ones that I love talking about is they use a centrifugal blower for a mister that's used at restaurants. So if they're based down in Florida where it gets hot and humid all the time. At the amusement parks, they got these big blowers that blow and mist air over large area that will cool down any guests that are at a park or at a restaurant, so they can maintain those cool, and as well as the device is meant for those outside environments. They don't have to worry about it.
So you mentioned say for instance, do a one in a fryer, so now there's other characteristics, right? So heat, things like that these fans may be exposed to. What are some of the key characteristics that make your fans different?
Yeah, I mean, the big thing that for Sanyo Denki products is we're trying to maintain as high of performance as possible. We are one of the leaders for the high-end performance side. So even our non-environmental fans give you peak performance. We use these things in stuff like data centers and stuff like that, but we leverage that technology base in our environmental protected products to give you both the high-end performance and as well as the protection in devices for whatever environment you need. One of the big ones that we talk about that Sanyo Denki does really well on is long life. Long life is something that's not necessarily a big target for a lot of other fan manufacturers. Sanyo Denki takes pride in the fact that we are the industry leader in longest life in the industry. We actually have fans that some of them run up to and are rated for 23 years of continuous life. So you can stick those in and not have to worry about a fan for maintenance costs. You don't have to worry about a fan for going down in critical environments. Medical is one of those things as well. If you don't have a fan that you want to have a device running for 10 plus years, you don't have to worry about it if it has those extra ratings involved on it. And we do that in a very unique and interesting way. We actually take those long life fans and they use an aluminum frame on the fan to help dissipate heat, as well as using specialty bearings inside that help protect that fan and make sure it's running as optimally as possible.
You guys also really pride yourself on reliability, and you talk about long life, but reliability in general. And I'd love it if you could talk to us a little bit about the testing process and what that entails.
Yeah, absolutely. Sanyo Denki tests 100% of our products. That's something that we make sure is baked into every one of our fans. Every single fan that leaves our factory is tested and validated for a variety of different things, making sure the speed is correct on the fan, voltage correct, any sort of current draw, noise, if that's a concern. We do test for noise before these fans leave our facility to make sure they aren't accidentally damaged or something like that before they leave, as well as making sure any of the extra features, PWM, sensors, anything like that are all working properly before they get to a customer's hands. We rate all of our fans for as high of ratings as possible on any sort of life. So we actually test them at higher temperatures than most of the other competitors in the market, just to make sure these fans are going to give you as good of a product as possible. Makes my job super easy because I don't have to worry about anything coming back failing. When we have something like 10 parts per million of fans coming back a year as failed. I've never seen anything that low before, but I love it. It makes it so I don't have to worry about it.
All right, so in a lot of designs, we've seen multiple types of cooling mixed together, right? How do your fan solutions pair with other types of cooling that are out there? Like, how do you pair those?
Yeah, I think a big component of a lot of designs nowadays is kind of adding together and integrating different devices together, and that's one thing that we've worked with Sager some on with how they work with their design houses, integrating other products that they sell with the fans that we work with. So you can do that in a variety of different ways. Heat sinks are a great one, as well as harnesses and bracket assemblies for installing the fans themselves into a system, making sure it's as easy as possible. Maybe Vineet can touch on a little bit on what they can do for doing those extra integrations.
Yeah, absolutely. Yeah, heat sink's the big one for sure. And so, the heat transfer coefficient is something that I wanted to talk about, which is this weird word. It just basically means the capacity of air to cool something, right? And that capacity of air to cool something goes up as you increase velocity. But what people don't realize is that the having a fanless solution, which is one of the options that some people can do, you need a lot more metal. You need a lot more heat sink. You need a bigger housing, because the natural capacity of, just think about if you have really hot food and you let it kind of cool on its own versus you blow on it. It's a huge difference, right? And so the heat transfer coefficient for natural convection, no fan, is somewhere like 5 to 7. And then when you start introducing even a little bit of airflow, it starts ramping up very quickly into 20s, 30s. Even at 5 meters per second, it goes up to 30, 35. So it's way higher. And so pairing up even a small, quiet fan, like Sanyo has some good silent series fans, for example, pairing those up with a small heatsink can replace a big extruded or die cast heatsink, and that can make a huge difference.
So that kind of actually, I had a question, and Vineet, I think that was a really nice segue, because my question was, how did we cool things before we had fans? And obviously, I'm talking about electronics, and you talk about fanless solutions. But what were the actual solutions before, an engineer said, "Hey, let's use a fan to cool down these electronics"?
Yeah, fans are a very old technology, so I don't know historically how things kind of evolved with each other, but there are design trade-offs that people make today about whether or not to include fans, and especially in outdoor environments, where it can be difficult to say, if people are used to speccing in those old fans that weren't IP rated, then they were used to, the service issues that Brian talked about, and they're like, well, we don't want a fan on this one because we'd have to send people out there to service it, which is not really the case if you choose the right fans now. But yeah, what they used to do is just say, okay, I have this much heat, so and my maximum temperature outdoors might be 50 degrees Celsius. Okay, I need a 2 foot by 3 foot piece of aluminum that's has huge fins on it. Die casting is going to cost $20,000 to tool this up. And if you go see chassis, telecom chassis out there, some of the older ones, you'll see big hunks of metal out there because they don't have a fan. And so that's a big trade-off there.
So the heat sink, or whatever we're going to call it, the big chunk of metal, was before the fan, sort of, is what we're saying, right? So
again, I don't know if it was historically like that's what it was, and then fans came into play, because there's always been interplay, between active cooling and passive cooling, and the design trade-offs have gone back and forth, and the fans became better and better, so more people started using fans and things like that. So I don't think it was necessarily one way or the other. You see the same thing in liquid cooling, where it's like liquid cooling kind of goes in and out of vogue sometimes, depending on what the application's doing. But certainly some of the new fan technology has opened a lot of people's eyes to say, okay, now it's going to last 23 years and I don't have to worry about dust. Well, why am I spending all this money on this, big extrusion or die cast metals?
Right. Well, I think you brought up a good point, and maybe we talk about that a little bit, like active versus passive, right? Because, heat sinks and those big chunks of aluminum that it was just, cooling out were very passive methods, where now it's more controllable, right? When you have an active method, because, if you look at really old electronics, look at the, first generation of personal computers, they would shut down they got too hot, or if it was too hot in a room, they would literally shut down, because they overheated, and fans really became an active way of countering that.
Does liquid cooling fall into active or passive, or is it kind of a category of its own?
Well, I think you can technically say it's active cooling, but yeah, it would be its own thing. Okay. Yeah, for sure.
Yeah,
Ryan, I don't know if you want to talk about the
Yeah, sorry. I was going to say, to tie into what you're talking about, I mean, it's really the big change here from and using passive versus active is a lot of talk about size and what devices size are nowadays, and how much power you're trying to pack into a smaller package. You were talking about computers. Look at computers from even 10, 15 years ago, how much bigger they were, because the components that were inside them just weren't at the micro scale that we're talking nowadays. Right. And so they had the extra space already just because of the limitations of the hardware, that they could get away with just airflow flowing through them for the most part to be able to cool those devices. Nowadays, you talk about those old IBM computers that used to take up an entire room. Now those things are the same amount of memory on a memory stick that's this big. I mean, you're talking magnitudes of scale different, and because of that, you're packing in a lot more power into a lot more smaller space, and a lot more power means a lot more heat. And so in order to get rid of that heat, you need to have that active solution in play. And that's really the big change over time, has been, you're talking about those big devices, they have all that active cooling, or I'm sorry, all the passive cooling they need, just because they're so big that they can have those big heat sinks on them. Nowadays, you don't have that luxury.
Yeah. And you look at that, half the space inside of them was just space for air to circulate through, and there were a lot of vent holes, right? You talk about even 10 years ago on like a desktop computer, it was a lot of vent holes just so air could, and those are very fan cooled also, but there's a lot of empty space because of, the heat. Now I have a question. Are there any case studies or examples you guys want to share with us? That'd be really cool.
Yeah, absolutely. I've actually got a couple good ones. Do you mind if I share a few?
Yeah, you can share.
All right. All right, here's the first one we can look at. This is a good case study of an application case that we actually put fans into digital signage. And this is used for, if you ever go up to McDonald's, you see those big screens that they now have that are all the digital displays for showing the menus and showing what their specials are of the day. Those all have fans inside of them because they're all large electronic devices. Those monitors that are used in there are holding in a lot of heat, and they need to get a lot of heat out, as well as these could be installed anywhere. You could talk about these things being placed in Arizona. I think the Arizona average temperature during summer is somewhere around 100 degrees Fahrenheit and can hit upwards of 120, 130 degrees on a really bad day. So you got to have that concern for when designing these devices, as well as on the opposite end. These could be up in the mountains and of Colorado and be snowed in the winters and worry about
and there's no way you're dissipating that with passive
right exactly. And so a lot of what Sanyo offers for these sort of applications is going to be the extra passive or active cooling that we were talking about earlier. And that active cooling will have the extra IP68 rated protection to protect these fans in those external environments. This fan actually has a bunch of fans on the back side of this unit to help circulate air internally on these digital signage displays. We actually are using our SanAce brand 120 millimeter frame size fans. Here's just some general specs about these specific fans. The 9W V12 fan is an IP68 rated, 120 by 120 by 38 millimeter frame size, 48 volts. We offer a few different varieties of different voltages for fans to use, as well as this one uses PWM control function. And that PWM control basically allows you to change the speed of the fan depending on how much cooling you need and how much power draw you want to use at any single time. So during those high points in summer, you want these fans cranking at 100%, running as high as possible to make sure these things are as cool as possible. But during winter, they may not be needed. So you can turn it down all the way down to 0 to 20%, and the fans will stop or be running at a kind of an idle speed to get a little bit of airflow through it. A little bit of airflow flowing through the device to make sure that it doesn't overheat, but you don't have to worry about it in those colder temperatures.
And that's a good point because if you're able to vary the fan speed, right? Whether you're making that sign for, like you said, Arizona or whatever, Minnesota, where
Yeah.
you have extreme temperature differences, you could vary that, and the manufacturers could design the same piece, with the same fan, create all the same versus swapping out different things that are.
Exactly. And that's kind of our design philosophy for a lot of these, is making it as easy to use in a wide variety as possible for anybody looking
Right.
at these.
Is there a reason? So on the back, we see in that image, right? You have some of the airflow going up and out, and some of it going down and out. Is there a reason? That's just how the electronics are designed in this one?
I think that's just kind of a visual for this one in particular. Most of these designs, it depends on how you're designing it. This one is working on actively cooling the back sides of the monitors inside the device. So air is pulling in from the outside, blowing over internal heat sinks on the back of the monitors to help airflow over those devices. So the airflow is just coming from one side and blowing elsewhere. Sometimes we see these as just circular systems. They have it so airflow just cycles up and around through a system inside a device, and it's all just up to the design engineer and how they want to work with that airflow. So for this specific fan, really the big technology we're talking about is that IP68 rated protection. And you can see a little bit here on this image, that actual encapsulation, everything here in red is an epoxy coating over the electronics to keep everything from being affected by any water or dust. And really what that allows you to do is a splash-proof fan in these environments. You don't have to take extra design precautions to prevent any of that ingress. A lot of conventional methods would need a big shield or a cover or bearing the fans internal in the system. They may not be as efficient doing that way. These things, you don't have to worry about it. Stick them on the outside of the system, and they're going to be able to operate in any sort of environment that you put them into. Let's pull up another one. This is a fun little one that I like as well. That's kind of showing off the new technology coming out these days, and what we can see for stuff coming in the future, even if it's a little scary, of little robots rolling around all over the place. This is actually a food delivery robot. I don't know if anybody you guys live in those big cities or have been to big cities recently where they have these little things rolling all around delivering Uber Eats or DoorDash or whatever it is. So they don't have a delivery driver. It's just a little robot that shows up to your door, and you can go and grab your food out of the bin when it's ready. And these things have similar concerns to the digital signage side. They need that IP protection as well. However, these, since they're a device that you want to be using for as long as possible to get as much value out of your product as possible, these also use a new hybrid product that Sanyo Denki has been developing for the past few years, which is a splash-proof and long-life fan. So it kind of takes the two families and marries them together into one product. You get the full IP68 protection with that full epoxy coating around the electronics, but you also have that aluminum frame we talked about earlier to help dissipate heat out of these products. So for this specific device, they're in need of cooling of their electronics, but they don't want to have any sort of worries of the quality of this product over time. So they're using these 9WL06 fans, which is an IP68 rated fan, but also long life up to 180,000 hours at 60 degrees C of continuous usage. So these things are running somewhere in the ballpark of 15 to 20 years of continuous usage, and the fans will be running fine. So you don't have to worry about them as your component that's going to break down first.
So is this, I mean, it's interesting. You're talking about a delivery robot, right? So it's based on whatever power it has, right? It starts off when it goes to deliver. Now, do these fans also cycle on it? Like I would build in sensors so it knew it was empty to cycle the fans off if it doesn't need to stay cooled or slow it down. Do they do things like that in here?
Yeah, absolutely. So this one does have that PWM control function as well. So that's basically gives you an input into the fan to control it however you want. And a lot of our customers take that and use it for those sort of applications. For something like this, that's on a set device that has a limited amount of power supply. If it's running in a city like Denver, where it's cold during the winter, you don't need the fan on. You can have the fan off, save that power for your next delivery trip instead of having to worry about going back and charging up. Instead of, if you have a need for internal devices, they usually have some sort of thermistor or thermal sensor inside their device that'll tell them, hey, your devices are heating up. Maybe turn on the fan a little bit, cool it off a little bit in here so we don't have to worry about this thing overheating.
That's awesome.
I think those are the couple that I wanted to show for today. Those are kind of fun ones. I like those because they kind of show the products and are fun new technologies to talk about as well.
Yeah, I like that. I like that it's controllable, honestly. That's like a huge thing with a lot of those applications we just talked about.
Yeah, one of the things too on that first one that you showed, Ryan, is different design touch points that when folks are designing have to consider. So it's not just, replacing, hey, can we go to a fanless design, whatever. A lot of times, even simpler components like power supplies can have a huge effect on whether there's a little bit of airflow in there or not. A lot of these open frame AC/DC power supplies are rated for, let's say 100 watts, but if you don't have at least 10 CFM of airflow, which is very nominally small airflow, then it's going to be rated only for 70 watts. So now all of a sudden the engineer has to go and say, well, I need to go to the next level up of power supplies if I don't have fans in there so that I can derate and then still provide the 100 watts that I need. Now all of a sudden cost goes up. And so there's this cascading effect that happens. And if you can find the right fans to just, do the job for you, it can be cost savings as well.
Yeah, and those costs kind of do trickle down, as you mentioned, depending on what sort of device you're working with. Something like this food delivery robot that we talked about, having that long life in there, it's maintenance costs. And replacing the fans, 180,000 hours is nothing to joke with. I mean, that's a long time. Standard fans usually have a life somewhere in the ballpark of 4 to 5 years, depending on the manufacturer's ratings. That means that this one fan can be an alternative instead of replacing the fan up to 3 to 4 times in its lifetime. So instead of your cost being one fan versus one fan, it's one fan versus 3 fans over the life of a product. As well as the extra maintenance costs. You're paying a guy to go out there and fix the device and change out the fan. So
on a whole fleet of robots,
Exactly. So it's a cascading thing of, if you do the due diligence ahead of time and pay a little upfront cost for the nicer and more efficient fan for your device, you're going to get a lot of gains long term out of these things.
Ryan, going back again on that first one, this is a question from me, I guess. How does a design like that protect against like rain and stuff getting into their electronics? So the fans are fine if it's raining, but
I was thinking the same thing, actually.
Yeah.
So the screen one, the digital signage one, is actually very interesting how they do their design. They actually have a dual chamber system. So they actually have 2 sets of fans in their system. There's some that are internal inside the system that are non-IP rated, that just cycle air through the inside of their system, and they have a cooling system internally, as well as the external fans, which cycle through a set of chambers inside the system that is a sealed chamber, and then they use heat sinks on either side to mitigate heat in between the 2 chambers. So the outside is sealed, the inside is sealed. The external fans are very crucial, though, because they are external to the system and having to circulate air through those heat sinks that they have on the external chambers of their system.
Yeah, and that's that type of design is a good way of combating that issue in general. And you can even do that with putting thermoelectric coolers or peltiers. If you put that in between the 2 heat sinks that you were talking about, Ryan, then that can allow you to go below ambient. You need a lot more airflow to deal with peltiers there, but you can, you don't need IP rated fans on the inside, so you can put a lot more fans or higher RPM fans or whatever you might need to do on the inside, and then the outside fans are IP68 rated and can withstand the rain. That's perfect.
And bringing back to our point of how do you integrate different types of fan cooling methods together, that's a really good example of it, where you're taking the advantages of heat sinks that are the passive cooling and integrating them with those active cooling fans to get the best product possible.
So I always like to close out by asking our friends at Sager how they helped us support our suppliers. And Vineet, I'd like to ask you specifically how you work to support Sanyo Denki and even what you're hearing from the engineers in regard to this topic. to this topic?
Sure. Yeah, absolutely. Well, we're Sanyo Denki's #1 distributor, and Sanyo Denki's our #1 fan line here at Sager. So we obviously work very, very closely with each other. Some of the ways that I support a lot of our customers is by having those other accessory solutions like heat sinks and thermoelectric coolers. We also help just do value add solutions onto standard fans by adding connectors or adding a fan guard. Customers that might need help with figuring out how much airflow they need. Sanyo Denki has airflow testers for fans and for testing system curves. So just on a facilitation basis, that's something we help them do. And then also just on the ground level, we are able to stock these standard fans and also standard modified fans so that when customers get those fans, a lot of times it already has the connector, already has the grill. Often we'll put it on a heatsink if it's a what they call a fan sink type solution, or if it's a dual heatsink type solution, we'll put fans on either side of that with everything. So by the time the customer gets it, they just put it right in their system, and it's good to go.
All right. And lastly, Ryan and Vinny, can you please let everybody know where they can learn more about Sanyo Denki's solutions out there?
Yeah,
Ryan?
absolutely. Sanyo Denki has their website, sanyodenki.com, as well as you can reach out to any of our supporting staff to help out with that, as well as Sager has a dedicated product page for Sanyo Denki products on their website as well for viewing our products. We're always happy to help and give any advice, as well as help with any customizations or designs that we do. It's something we love talking about fans, and why not bring us in and help you out with what you need.
Yeah, and like Ryan said, we do have dedicated pages for different different product lines, as well as the just Sanyo Denki in general, and we also collaborate with them to put out different materials over the year. Just for people's knowledge as new products come in and new applications come in.
Well,
Awesome.
Thank you
Thank
both
you
for
so
joining
much.
us.
Absolutely. Thanks for having us.
Yeah, thank you for having us.